Well, and today we're going to be talking about 4 different proofs with parallelograms. Now, there's many different proofs you could do with parallelograms. I've just chosen these 4 to work with for my particular classes. If you need to see more of these things, you should talk to your individual teachers. So first one is we're going to prove that the opposite sides of a parallelogram are congruent. So we're given that ABC, D is a parallelogram. We want to prove that the opposite sides AB and CD are congruent to each other, and then AD and BC are also congruent to each other. So like always, we're going to start with our given statement first. Now, with all the proofs we've been dealing with, generally the first thing we want to talk about is we need to actually have some sort of triangles in the problem. So I need to draw a line from A to C to form 2 triangles. If I can show 2 triangles are congruent, I can then work proving sides are equal by corresponding parts. So I want to draw line AC. And that's our line postulate. So now that I have my 2 triangles, ABC and CDA, well, I need to prove their congruence. Well, they're going to form a bunch of angles in here, so we'll call these angles 1, 2, 3, and 4. And they have this shared side AC. Well, if they have a shared side, it must be congruent to itself. So AC is congruent to AC. That's our reflexive property. Now, we need to work with something else. Again, I can't work with AB and CD or BC and AD. I'm trying to prove that. And I can't work with these angles just yet because I don't know I have parallel lines. However, we go back to the thing that we're talking about. We're talking about ABCD is a parallelogram. Our definition of parallelogram stated that opposite sides are parallel. So if I have a parallelogram, I can immediately say that AB is parallel to CD, and then the AD is parallel to BC. That's our definition of a parallelogram. I'll use the parallelogram symbol to draw that. Now that I have AB parallel to CD and BC parallel to AD, I can now say I have my alternate interior angles. 1 and 4 are equal, 2 and 3 are equal. Those are both alternate interior angle pairs. And now I have enough information to say that the 2 triangles are congruent. So I can say triangle ABC is congruent to triangle CDA. I have 2 angles congruent, the side in between. So it's angle, side, angle. And then our last statement is always going to be the proof statement. I now have congruent triangles AB and CD are in the same spots, so are BC and AD. So they're in corresponding parts, therefore they're equal. So AB is congruent to CD. And then AD is congruent to BC because their corresponding parts of congruent triangles are congruent, are CP, CTC. So there's a proof showing why that the opposite sides are congruent if this is a parallelogram. We first need to draw a line AC. We could have drawn BD, it didn't matter. We had a reflexive side. We had to talk about the fact that the opposite sides are parallel already because it is a parallelogram. That formed alternate interior angles, gave us our congruent triangles, to then say our corresponding parts. So there's our first proof. Our next one is the parallelogram diagonal congruence. So we're going to prove why the diagonals bisect each other. So we're given that ABCD is a parallelogram, we want to prove that AE is equal to EC, BE is equal to ED. Again, we're going to start with our given statements. Now in this one I don't have to draw any lines, so I can immediately go with the fact that, well, I need to talk about parallel sides again. Because in order to work with angles 1 and 4, 2 and 3, I need to know that the opposite sides are parallel. So I need to say that AB is parallel to CD, and that AD is parallel to BC, because that's our definition of a parallelogram. By having the sides parallel, 1 and 4 are both alternate interior angles, so are 2 and 3. So I can say angle 1 congruent to angle 4, angle 2 congruent to angle 3, because they are alternate interior angles. Now, I have 2 angles. I could talk about this third angle pair right in here. The vertical angles are equal, or the fact they're equal to the third angle, but I don't need that. I need a side some way. Now, AE and ED, BE and EC, all those diagonal sides, I'm going to prove them in the end, so I can't work with them now. Leaving just BC and AD for those two triangles. Well, they're opposite sides. This is a parallelogram. I couldn't say that they're equal in the previous proof because I was trying to prove opposite sides congruence for a parallelogram. But any other proof, I can use that. So I can say that AD is congruent to BC because of our parallelogram side congruence. Again, parallelogram symbol, congruence symbol, just abbreviations. So that gives me the pair of sides I need to work with the triangles to make them congruent. Because now I can say the triangle BEC, the top triangle, we're going to triangle DEA, bottom triangle. We have two angles congruent, the side in between, that's angle side angle. And that finally leaves us, last statement is going to say then, now that I have congruent triangles, AE and EC, BE and ED are on the same spots. They're corresponding, so therefore they're congruent. AE congruent to EC, BE congruent to ED, because their corresponding parts of congruent triangles are congruent. So there's our second parallelogram proof. We're proving why the diagonals are going to bisect each other to form congruent segments. Our third one now, the next one are going to be converse proofs, essentially. I'm going to prove why I have a parallelogram. So now we're given that AB is congruent to CD, and that AD is congruent to BC. I want to prove why this makes this have to be a parallelogram. That's our goal. So again, we're going to start with our given statements. Now, like with all of the proofs, we need to work with triangles. I don't have any, so let's draw some. So let's draw a line AC. So we're going to draw AC. We can draw a line because of the line postulate. And if both triangles share the same side, that side must be equal to itself. So AC is congruent to AC. That's our reflexive property. We notice that our two triangles now have all three side segments marked off. So I can say the triangle ABC is congruent to triangle CDA. That's because of side, side, side. So the whole goal is to prove triangles are congruent to then get to the next couple steps. Now, I'm trying to prove that this is a parallelogram. This shape is a parallelogram. So our definition of parallelogram said that opposite sides are parallel. So if I can show opposite sides are parallel, I can then say it's a parallelogram. Well, in order to get sides parallel, I need angles. That's why we had to show the triangles are congruent, because now I can say that angles 1 and 4, and then 2 and 3 are both equal, not because they're alternate interiors, because even though that's what the angle designation is, they're equal because they are corresponding parts of the two congruent triangles, or CPCTC. That's why they're equal, not because they happen to be alternate triangles anyway. Because they're alternate interiors, it means their opposite sides are parallel. So AB is parallel to CD, AD is parallel to BC. That's our alternate interior angles converse. And now that I have opposite sides parallel, both pairs of them, that makes this shape a parallelogram. ABCD is a parallelogram. That's our definition of a parallelogram. So when we're trying to prove something is a parallelogram, we're going to have to end obviously with that statement, and we're going to end with because that's what the definition is. We're trying to prove the statement right before it that both pairs of opposite sides are parallel. That's the whole goal. And generally to prove lines are parallel, you're going to need to talk about angles. So that's why we had to prove the angles 1 and 4, 2 and 3 are the same. In order to get angles the same, I need triangles congruent, most likely. That's why I need to show the triangles are congruent, which is why I need to draw the AC and talk about it being equal to itself. So again, there's a logical progression, logical reason behind where each one of these things are coming from. Alright, one more. So now we're given the same pair of sides. AD is congruent to BC, and AD is parallel to BC. I want to show that why that means, because the same side is both equal and parallel, that this really is a parallelogram. Like we know, for example, a trapezoid has the two bases, the two opposite sides are parallel to each other, but they're not the same length. The reason why they're not the same is because if they were, this would form immediately a parallelogram. So that's why we're going to prove right here. So we first start with our given statements. Like with everything else, we need to work with triangles, so I need to draw a line. So again, we're going to draw AC. If you want to draw BD, it wouldn't matter. It'd give you the same kind of proof. So we want to draw AC. That's our line postulate. And again, both triangles share that sign, so I can say this side is equal to itself. AC is congruent to AC. That's our reflexive property. Now, I don't know anything about any sides A, B, and CD, so I can't go that route. I'm going to need an angle then. Well, BC and AD are both parallel to each other. These form these lines. We'll talk about these angles inside here. Now, 1 and 4, you're attempted to say they're equal because they're alternate interiors. But that's not true yet. 1 and 4 are, yes, alternate interior angles, but the lines that form them are AB and CD. AB and CD form angles 1 and 4. But I don't see AB parallel to CD in this proof. So the goal is, since I already have one pair of sides parallel, if I can show that AB and CD are parallel, I can then say it's a parallelogram. So to show that they're parallel, I need to show that 1 and 4 are congruent. And to show that 1 and 4 are congruent, I need to show that I have congruent triangles. So I already have two sides. I do notice angles 2 and 3. They're both alternate interiors, and they're formed by a given pair of parallel sides, BC and AD. So I can say that angles 2 and 3 are congruent because of alternate interior angles. This now gives me enough information to say whether my triangles are congruent. So triangle ABC is congruent to triangle CDA. This time I have two sides equal in both triangles and then the angle in between them. So that's side angle side. Because the triangles are both congruent, angles 1 and 4 are both in the same spots, or opposite the single tick mark side. Therefore, they're congruent not because they're alternate interior, but because they are corresponding parts of congruent triangles. Because the pair of alternate interior angles are now congruent, I can now say AB is parallel to CD. That's our alternate interior angles converse. And now that I have BC parallel to AD from the given statement, and I just proved that AB and CD are both parallel, and now both pairs of opposite sides, I can now say that ABCD is a parallelogram, because that's its definition. Both pairs of opposite sides are parallel. And there's our last proof. Again, there are many more proofs you can work with. Again, each one of the properties of parallelograms, you could prove that the opposite angles are equal, that the consecutive angles are supplementary. You can prove the converse for each one of those, proving that if I have opposite angles congruent, that means it's a parallelogram. If I have consecutive angles consecutive angles supplementary, that means it's a parallelogram. The diagonals, if I have the diagonals bisecting each other, that means it's a parallelogram. There's a whole bunch of proofs you could write with this. I also could do proofs with the rhombus, the rectangles, the squares. All those properties are proofs you can write, and depending upon your teacher, you may be doing those. I've just decided not to do those proofs for my class, focusing more instead on the mathematical properties. So my students are all going, yay! Other students may be not going yay, and that's fine. Okay, so next time we will be dealing with, again, different properties of our other shapes. Again, a rectangles, a rhombus, trapezoid, stuff like that. So I will see you next time.